Welcome back to Deep Space Dreams, where we drift through the deep past one story at a time. Tonight, we're going on a slow, soothing journey into one of the most intriguing cosmic mysteries of recent years. A mystery that asks us to consider whether some of the strange visitors passing through our solar system might be more than they appear. What if the objects we call comets, those ancient wanderers from the depths of space, aren't all born from ice and dust? What if some of them were built? As always, I hope this video helps you drift off gently, or at least helps you put your worries into perspective by zooming out a few 100,000 years. Of course, there's a small risk that it might be too interesting and keep you awake. But if that happens, well, at least you'll have learned something fascinating along the way. Before we float off into the past together, I'd love it if you gave this video a like and maybe even subscribed if you haven't already. It really helps this sleepy little channel grow. I'd also love to know where you're watching from and what time it is for you right now. Let me know in the comments. It's always such a joy to see our sleepy history community scattered gently across the globe. Now, settle in. Get comfortable. You don't need to remember any of this. You don't need to take notes or stay alert. Just let the words wash over you like whispers on the wind. And as we begin this gentle voyage into the vast unknown, remember this video is for educational and relaxation purposes only, and is not intended as medical advice. Ready? Let's begin. Picture yourself floating in the absolute darkness of space, far from any star, far from any warmth. The silence here is perfect, complete, eternal. There are no sounds because there is no air to carry them. There is no up or down, no day or night. Just an endless, peaceful void stretching in every direction for distances that the human mind cannot truly comprehend. This is the realm between the stars, the vast ocean of nothingness that makes up most of our universe. And through this silent darkness, things are moving. They have been moving for millions of years, perhaps billions, on journeys that began before our sun was born, before our earth took shape, before the first spark of life emerged from primordial waters. These travellers move slowly, patiently, carried by momentum from the events so ancient that their origins are lost to time. Most of them are simple things, chunks of ice and rock, the leftover building blocks of solar systems ejected into the void by the gravitational dance of forming planets. They drift through the darkness, cold and silent, until by pure chance, after eons of travel, they encounter the gentle pull of a distant star, our sun. And when they do, we notice them. We give them names. We call them comets. But on a quiet night in December 2019, astronomers working with the Asteroid Terrestrial Impact Last Alert System, or ATLAS, noticed something unusual. It was just a faint smudge of light at first, barely distinguishable from the background stars. The automated systems that scan our skies every night, searching for potentially dangerous asteroids, had flagged it as something worth investigating. At first, it seemed like just another comet, one of the countless frozen wanderers that occasionally grace our skies. They designated it C2019Y4, though it would soon become known simply as Comet ATLAS. What made this discovery special wasn't immediately obvious. You see, we discover comets all the time. Our automated sky surveys, with their patient electronic eyes that never tire, never blink, find dozens of them every year. Most are unremarkable, dirty snowballs from the outer reaches of our own solar system, following predictable paths around our sun. They come in from the cold, warm up as they approach the sun, develop their characteristic tails of sublimating ice and dust, and then retreat back into the darkness. It's a dance that has been happening for billions of years, a gentle rhythm of approach and retreat, like cosmic breathing. But as astronomers began to study this new comet more carefully, calculating its trajectory, measuring its brightness, analysing the spectrum of light reflecting off its surface, something extraordinary emerged. The path this object was following wasn't a closed ellipse around our sun. It was a hyperbola, an open curve that meant this visitor wasn't bound to our solar system at all. It was just passing through, on a journey that began somewhere else entirely and would continue long after it left us behind. This alone would have been remarkable. You see, in all of human history, we have only confirmed a handful of true interstellar visitors to our solar system. The first was Oumuamua in 2017, a name that means scout or messenger in Hawaiian. The second was Comet Borisov in 2019, and now Atlas appeared to be the third. But the story was about to become even more intriguing. To understand why, we need to pause for a moment and consider what it means for something to come from interstellar space. Imagine, if you will, the sheer scale of the journey involved. The nearest star to our Sun is Proxima Centauri, about 4.2 light-years away. That's approximately 25 trillion miles. To put that in perspective, if you could travel at the speed of the fastest human-made object ever launched, the Parker Solar Probe, which reaches speeds of about 430,000 miles per hour, it would still take you over 6,500 years to reach Proxima Centauri. And that's just the nearest star. The average distance between stars in our galaxy is about 5 light-years. In the vast spaces between them, the temperature drops to just a few degrees above absolute zero. There is no light except the faint glow of distant stars. There is no warmth. There is nothing but emptiness and silence for distances that dwarf anything we can experience on Earth. An object drifting through these interstellar voids might travel for millions of years without encountering anything at all. It would be preserved in this cosmic deep freeze, unchanged, unaltered, a perfect time capsule from wherever and whenever it began its journey. So when we detect an interstellar visitor, we're not just seeing a piece of rock or ice from another star system. We're seeing something that has travelled through the deepest, darkest, loneliest places in the universe. We're seeing an ambassador from another place, another time, carrying with it secrets about conditions and processes that might be completely different from anything in our own cosmic neighbourhood. As winter turned to spring in 2020, astronomers around the world turned their telescopes toward Comet ATLAS. What they expected to see was a fairly typical comet warming up as it approached the Sun. Comets, you see, are often described as dirty snowballs, mixtures of ice, dust and rocky material left over from the formation of planetary systems. As they get closer to a star, the ice begins to sublimate, turning directly from solid to gas, creating the glowing coma and tail that make comets such spectacular sights in our night sky. Atlas was still far from the Sun when it began to brighten, which wasn't unusual in itself. But the rate at which it was brightening was extraordinary. In just a few weeks, it increased in brightness by a factor of hundreds. Astronomers began to speculate that we might be witnessing the approach of a truly spectacular comet, perhaps one that would be visible to the naked eye, maybe even in daylight. The excitement in the astronomical community was palpable. Great comets, those bright enough to be seen easily without telescopes, are rare events, happening perhaps once or twice in a human lifetime. But then something unexpected happened. Just as suddenly as it had brightened, Comet ATLAS began to fade. And not just fade, it began to break apart. Through telescopes, astronomers watched as what had been a single, cohesive object fragmented into multiple pieces. It was like watching a dandelion seed head slowly dispersing in a gentle breeze, except this was happening in the vacuum of space, millions of miles from Earth. This fragmentation wasn't entirely unprecedented. Comets do sometimes break apart as they approach the Sun. The gravitational stresses combined with the rapid heating and outgassing can cause their fragile structures to disintegrate. But there was something unusual about the way ATLAS was fragmenting. It was happening while the comet was still relatively far from the Sun, farther than would typically cause such dramatic disruption. And the pattern of fragmentation was oddly regular, almost methodical, as if the comet was coming apart along predetermined lines. As astronomers continued to observe, the fragments themselves began to fade and disperse. Within weeks, what had promised to be a spectacular celestial show had dissolved into nothingness, leaving behind only a faint cloud of debris. It was as if Atlas had simply decided to cease existing, to dissolve back into the darkness from which it had emerged. The scientific community was puzzled. Why had this comet behaved so strangely? Why had it brightened so dramatically only to fall apart before reaching the point where solar heating would typically cause such effects? And perhaps most intriguingly, why had an interstellar visitor, an object that had survived millions of years travelling through the harsh environment of interstellar space, suddenly become so fragile upon entering our solar system? These questions might have remained merely curious footnotes in astronomical journals, interesting but ultimately unremarkable anomalies in our observation of the cosmos. But then some researchers began to notice patterns, connections to other mysterious observations, hints that perhaps what we had witnessed wasn't just the natural death of a comet, but something far more profound. To understand these connections, we need to expand our view, to look at the bigger picture of interstellar visitors to our solar system, and that means we need to talk about Oumuamua, the first confirmed interstellar object ever detected passing through our cosmic neighbourhood, and one of the most puzzling objects astronomers have ever observed. It was October 19th, 2017, when astronomer Robert Werrick, using the Pan-STARRS telescope in Hawaii, spotted something unusual. Like Atlas, it was initially just a faint point of light, moving against the background stars. But within days, it became clear that this was no ordinary asteroid or comet. Its trajectory was hyperbolic, meaning it had come from beyond our solar system and would return to interstellar space after swinging past the Sun. The International Astronomical Union, recognizing the historic nature of this discovery, gave it the designation 1/2017 U1, with the I standing for interstellar, the first object ever to receive such a designation. The team that discovered it gave it the name Oumuamua, and as telescopes around the world turned to study this interstellar visitor, the mysteries only deepened. First, there was its shape. Based on how its brightness varied as it tumbled through space, astronomers calculated that Oumuamua was extraordinarily elongated, perhaps 10 times longer than it was wide. Imagine a cosmic cigar or needle, tumbling end over end as it flew through space. No asteroid or comet in our solar system has such an extreme shape. It was as if we were looking at something fundamentally different from the space rocks we were familiar with. Then there was its composition. Despite passing relatively close to the Sun, Oumuamua showed no signs of outgassing, no coma, no tail, none of the typical features of a comet. It appeared to be dry, more like an asteroid. But its colour was reddish, similar to some organic-rich objects in the outer solar system, suggesting it might have been exposed to cosmic rays for millions or billions of years. But the real mystery came as Oumuamua left our solar system. As astronomers tracked its departure, they noticed something extraordinary. It was accelerating, not just following the curved path that gravity would dictate, but actually speeding up as it moved away from the Sun. The acceleration was tiny, just a fraction of a millimetre per second, but it was definitely there, and it couldn't be explained by gravity alone. In normal comets, such acceleration is caused by outgassing, jets of sublimating ice acting like tiny rocket engines. But Oumuamua showed no visible signs of such outgassing, no dust, no gas, no coma. It was accelerating, but we couldn't see why. This led to intense debate in the scientific community. Some proposed it might be outgassing hydrogen, which would be invisible to our telescopes. Others suggested it might be a piece of nitrogen ice, chipped off from a Pluto-like world in another star system. But these explanations required special conditions, specific compositions that seemed unlikely. And then there was the more radical possibility, one that made headlines around the world. What if Oumuamua wasn't natural at all? What if its strange shape, its unusual acceleration, its lack of visible outgassing were all because it was something else entirely? What if it was artificial? The idea wasn't as far-fetched as it might sound. In fact, some of Oumuamua's properties were remarkably similar to a concept that humans had already imagined: a light sail. A light sail is a proposed method of spacecraft propulsion that uses the pressure of light itself, either from stars or powerful lasers, to push a thin, reflective surface through space. It's a technology we're already experimenting with for interstellar travel. The Breakthrough Starshot project, for instance, proposes sending tiny probes to Proxima Centauri using exactly this method. If Oumuamua was a light sail, or contained light sail technology, that would explain its acceleration without visible outgassing. The pressure from sunlight itself would be pushing it along. It would also explain its unusual shape. A thin, flat object would be ideal for catching light, and it might explain why we didn't see typical comet activity, because it wasn't a comet at all. The scientific community was, understandably, skeptical. Extraordinary claims require extraordinary evidence, and while Oumuamua was certainly extraordinary, there wasn't enough evidence to conclude it was artificial. It had already passed beyond the range of our telescopes, speeding back into interstellar space, taking its secrets with it. We would never get a closer look, never be able to definitively determine what it was. But the questions Oumuamua raised didn't go away. If interstellar objects pass through our solar system, how often does it happen? What else might be out there, drifting through the darkness, that we simply haven't noticed yet? And perhaps most intriguingly, if an alien civilization wanted to study other star systems, wouldn't sending small, lightweight probes on million-year journeys be one way to do it? These questions were still being debated when Comet Atlas appeared in 2019. At first, it seemed to be a very different type of object from Oumuamua. It was clearly a comet, showing the characteristic brightening and outgassing as it approached the Sun. It didn't have Oumuamua's unusual shape or mysterious acceleration, but its dramatic brightening and sudden fragmentation added a new piece to the puzzle. What if, some researchers began to wonder, we were looking at this all wrong? What if Oumuamua and Atlas weren't completely different types of objects, but rather different examples of the same phenomenon? What if they were both artificial, but designed for different purposes or in different ways? Consider the possibilities. If you were an alien civilization wanting to explore the galaxy, you wouldn't send just one type of probe. You'd send many different designs, optimized for different missions. Some might be built to survive the journey intact, like Oumuamua possibly did. Others might be designed to break apart at their destination, perhaps to deploy smaller probes or sensors, or to spread material across a wider area. The fragmentation of Atlas could have been not a failure, but a feature. This brings us to an even more profound question. How would we recognize alien technology if we saw it? We tend to imagine alien spacecraft looking like our own technology, metallic, angular, obviously artificial. But a probe designed to survive millions of years in interstellar space might look nothing like our spacecraft. It might be designed to mimic natural objects, either as camouflage or simply because that's the most efficient form. It might be made of materials we don't recognize as artificial. It might be so old, so eroded by cosmic rays and micrometeorite impacts, that any obvious signs of its artificial nature have long since been worn away. Think about it this way. If you found a piece of advanced technology from 1,000,000 years in the future, would you recognize it as technology? Or would it be so far beyond your understanding that you'd assume it was natural? Arthur C. Clarke once said that any sufficiently advanced technology is indistinguishable from magic. But perhaps for astronomers studying objects in space, any sufficiently advanced technology might be indistinguishable from nature. This is the context in which we need to consider Comet ATLS and its strange behaviour. Yes, it could have been entirely natural, a fragile comet that happened to break apart in an unusual way. But it could also have been something else, something we're not equipped to recognize or understand. The universe is vast and old, and we've only been looking at it with modern instruments for a few decades. How much might we be missing simply because we don't know what to look for? As we contemplate these possibilities, it's worth remembering that the idea of interstellar visitors isn't new. For decades, scientists have speculated about the possibility of alien probes passing through our solar system. In 1960, Ronald Bracewell proposed that alien civilizations might send robotic probes to other star systems as a more practical alternative to radio communication across interstellar distances. These Bracewell probes would be autonomous, capable of surviving the long journey between stars, and possibly capable of self-replication once they arrived at their destination. The concept makes sense from an engineering perspective. Radio signals weaken with distance, and a conversation between star systems would take years or decades for each exchange. But a probe, even travelling at a fraction of the speed of light, could eventually reach another star system and study it in detail, perhaps even establishing communication with any civilizations it found there. If such probes exist, they might have been passing through our solar system for millions of years, unnoticed until now. Some researchers have even suggested that our solar system could be littered with ancient alien artifacts, dormant and waiting. They might be in orbit around the Sun, hiding among the asteroids, or even on the surfaces of moons and planets. We wouldn't necessarily recognize them for what they are. After millions of years, they might be covered in dust and impact craters, indistinguishable from natural objects unless we looked very closely. This idea, sometimes called the Sirius Mystery, or the Sentinel Hypothesis, after Arthur C. Clarke's short story The Sentinel, which inspired the movie 2001: A Space Odyssey, suggests that alien artifacts might be deliberately placed where emerging civilizations would find them once they reached a certain level of technological development. Finding and recognizing such an artifact would be a kind of test, a way for an emerging civilization to announce its presence to the galactic community. Could Oumuamua and Atlas be examples of such artifacts? It's impossible to say with certainty, but the timing is intriguing. We've only had the technology to detect and track such objects for a few decades, and already we've found several interstellar visitors with unusual properties. Either such objects are much more common than we expected, or we're extraordinarily lucky to have spotted them so soon after developing the capability to do so. Or perhaps it's not luck at all. Perhaps these objects have always been passing through, and we're only now reaching the technological level where we can notice them. Like a child first learning to read, suddenly realizing that those marks on paper have meaning. We might be just beginning to recognize the messages that have been passing by us all along. As we think about these possibilities, drifting deeper into contemplation, it's important to maintain a balance between skepticism and wonder. Yes, the most likely explanation for both Oumuamua and Atlas is that they're natural objects with properties we don't yet fully understand. The universe is full of phenomena we're still discovering, and it would be premature to jump to artificial explanations without more evidence. But at the same time, we shouldn't dismiss the possibility entirely. The universe is vast and ancient, and the emergence of life and intelligence might not be unique to Earth. If other civilizations exist, and if they've had millions or billions of years to develop technology, then the galaxy could be full of their artifacts, drifting silently through the void, carrying messages or purposes we can't yet fathom. The story of a TLAS takes on new dimensions when viewed through this lens. Its dramatic brightening could have been the activation of long-dormant systems, powered by our sun's energy after eons in the cold darkness. Its fragmentation might not have been a destruction but a deployment, perhaps releasing microscopic probes too small for our telescopes to track, or spreading material designed to be detected by any civilization monitoring their skies. We observed Atlas for only a few months, from discovery to dissolution. In cosmic terms, that's less than a blink of an eye. Whatever secrets it might have held, whatever its true nature, it's now gone, dispersed into fragments too small and faint to study. Like Oumuamua before it, it has left us with questions but no clear answers, mysteries but no solutions. But perhaps that's as it should be. The universe doesn't owe us easy answers. It doesn't conform to our expectations or timelines. It unfolds at its own pace, revealing its secrets slowly, if at all. And in that slow revelation, in that gradual accumulation of knowledge and mystery, there's a kind of beauty. We're like detectives working on a case where the clues are scattered across light years, and the witnesses speak in languages we haven't yet learned to understand. The fragmentation of Atlas, when viewed in slow motion through telescope imagery, has an almost ethereal quality. The comet doesn't explode or shatter violently. Instead, it seems to gently come apart, like a flower opening in reverse, or like morning mist dissipating as the sun rises. The fragments drift apart slowly, each following its own path, each carrying its own portion of whatever story Atlas had to tell. Some of these fragments continue to show activity, brightening and fading in patterns that astronomers struggle to predict or explain. Others simply faded away, becoming too dim to track, lost among the countless points of light in the night sky. It was as if Atlas was deliberately making itself harder to study, fragmenting into pieces too small and numerous to follow, ensuring that its secrets would remain hidden. This behaviour, this seeming evasiveness, could of course be entirely natural. Comets are fragile things, held together by weak forces, easily disrupted by the competing pulls of gravity and solar radiation. But it could also be something else. If Atlas was artificial, its fragmentation might have been a kind of self-destruct mechanism activated to prevent its technology from being captured or studied. Or it might have been something more benign, a dispersal pattern designed to maximize coverage, to spread sensors or beacons across the widest possible area. We'll never know for certain. Atlas is gone now, its fragments either too small to detect or having long since passed beyond our ability to observe them. But the questions it raised remain, adding to the growing catalogue of mysteries surrounding interstellar visitors to our solar system. As we move through this contemplation, drifting like those fragments through the darkness of space, we're reminded of how much we don't know about our cosmic neighbourhood. Every year, thousands of asteroids and comets pass through the inner solar system. Most are catalogued and tracked, their orbits calculated and their compositions estimated. But some slip by unnoticed, too small or too faint to detect until they're already leaving, if at all. How many interstellar visitors have passed through our solar system without us knowing? How many are passing through right now, silent and invisible in the darkness? The detection of Oumuamua and Atlas suggests that such objects might be far more common than we once thought. Some estimates suggest that there could be thousands of interstellar objects in our solar system at any given time, most too small or too distant to detect with current technology. Imagine them out there, drifting through the darkness. Some might be simple chunks of rock and ice, ejected from distant star systems by the same processes that scattered debris in our own solar system's youth. But others might be something more. They might be messages in bottles, cast into the cosmic ocean by civilizations we'll never meet. They might be scouts or surveyors, mapping the galaxy one star system at a time. They might be seeds, designed to spread life or information across the vast distances between stars, or they might be monuments, markers left by civilizations that have long since vanished, their only legacy these silent sentinels drifting through eternity. Just as we've sent our own probes, Voyager 1 and 2, Pioneer 10 and 11, into interstellar space, carrying messages for anyone who might find them, other civilizations might have done the same. Atlas could have been such a monument, finally crumbling after millions of years, its message lost forever. The thought is both melancholy and beautiful. Somewhere out there, the fragments of ATLAS continue their journey. They're too small to see now, too faint to track, but they're still moving, still carrying whatever they've always carried, whether that's simply the frozen remnants of ancient ice and dust, or something more purposeful, more designed. Each fragment follows its own path now, influenced by the gentle pull of planets, the pressure of solar wind, the tiny pushes of radiation and magnetic fields. Over time, they'll spread apart, becoming an ever more diffuse cloud of particles. Some might fall into the sun, vaporizing in its nuclear furnace. Others might be captured by planets, becoming tiny meteors burning up in alien atmospheres. And some might escape the solar system entirely, returning to the interstellar void from which they came. In thousands of years, millions of years, those escaping fragments might encounter other star systems. They might pass through other solar systems where other astronomers, perhaps not even human, might detect them and wonder about their origin. They might catalogue them as simple meteoric material, never knowing that they once were part of something that puzzled astronomers in a distant system called Sol. This is the way of the cosmos, objects and information flowing slowly between stars, carrying stories that are mostly never read, messages that are mostly never received. It's a vast, slow, mostly silent conversation where the speakers might be separated by millions of years and the listeners might not even recognize the language being spoken. As we consider this cosmic perspective, our own concerns and timescales seem to shrink, but not in a way that makes them feel insignificant. Instead, they become part of something larger, a brief moment in an eternal dance. We're observers standing on a small rock, watching as mysterious visitors pass through our neighborhood, trying to understand what we're seeing with minds that evolve to comprehend much smaller scales and much shorter timescales. The mystery of ATLAS connects us to this larger story. Every time we look up at the night sky, we're potentially looking at objects that have travelled from unimaginable distances, carrying unimaginable histories. Some are natural, shaped by the same forces that shaped our own world. But perhaps, just perhaps, some are more than that. Perhaps some are attempts at communication, at connection, at bridging the vast gaps between islands of consciousness in the cosmic ocean. Even if Atlas was entirely natural, the questions it raised are valuable. It reminded us to look more carefully, to question our assumptions, to remain open to possibilities we haven't yet imagined. It showed us that even in our own cosmic backyard, there are mysteries we're only beginning to uncover, and it suggested that the universe might be far more interesting, far more complex than we've assumed. The brightness of ATLAS before its fragmentation was remarkable. For a brief time it promised to be one of the great comets of the decade, potentially visible to the naked eye, a celestial spectacle that would have captivated millions. Instead, it became a different kind of spectacle, a mystery that captivated astronomers and space enthusiasts, a puzzle that revealed how much we still have to learn about the objects that share our solar system. That brightening, that promise of visibility feels metaphorical somehow. It's as if Atlas was calling attention to itself, saying, "Look at me, notice me, remember me," before it disappeared. Whether that was the random result of natural processes or something more intentional, we'll never know. But the effect was the same. It made us look, it made us wonder, it made us question. And perhaps that's enough. Perhaps the value of objects like Atlas and Oumuamua isn't in the answers they provide, but in the questions they raise. They expand our sense of possibility, our awareness of the unknown. They remind us that the universe is not a solved problem, but an ongoing mystery, one that we're only beginning to explore. As we drift deeper into this contemplation, feeling the weight of cosmic time and distance, we can appreciate the profound privilege of living in an era where we can detect and track objects like ATLAS. For all of human history until very recently, such objects passed by unnoticed. They came and went in the darkness, their stories untold, their mysteries unexamined. But now, with our electronic eyes watching the skies, we can see them. We can track them, study them, wonder about them. It's a new chapter in humanity's relationship with the cosmos. We're no longer just passive observers of the lights in the sky. We're active participants in a cosmic detective story, gathering clues, forming hypotheses, slowly building our understanding of the universe we inhabit. Every new discovery, every anomaly like ATLAS, adds another piece to the puzzle. The fact that Atlas was discovered by an automated system, a patient electronic sentinel scanning the skies night after night, seems fitting. These systems never tire, never get distracted, never stop looking. They're our permanent watch, our guard against surprises from the darkness. And occasionally they find something truly surprising, something that makes us reconsider what we thought we knew. The ATLAS system itself, the Asteroid Terrestrial Impact Last Alert System, was designed primarily to find potentially dangerous asteroids, objects that might threaten Earth. It's part of our planetary defense network, our early warning system against cosmic impacts. But in looking for dangers, it also finds wonders. In scanning for threats, it discovers mysteries. It's a reminder that exploration and protection, curiosity and caution, are often two sides of the same coin. The name ATLAS is mythologically appropriate too. In Greek mythology, Atlas was the titan who held up the sky, bearing the weight of the heavens on his shoulders. Our Atlas system bears a different burden, the responsibility of watching those heavens, of noting everything that moves against the fixed backdrop of stars. And sometimes, like with comet ATLAS, it finds something that makes us realize the sky's far stranger than the ancient Greeks could have imagined. As we continue our journey through this cosmic mystery, we're approaching a transition in our understanding. We've examined the strange behavior of Atlas, its dramatic brightening and mysterious fragmentation. We've placed it in context with Oumuamua, that first confirmed interstellar visitor with its own set of inexplicable properties. Now, we need to delve deeper into what these objects might mean, what they might represent, and how they might change our understanding of our place in the universe. But before we take that next step, let's pause for a moment in the darkness. Let's float here in the void between ideas, between certainties, between the known and the unknown. This is where Atlas existed for most of its journey, in the spaces between things, in the vast emptiness that makes up most of the universe. It's a peaceful place despite its emptiness, or perhaps because of it. Here, there are no collisions, no conflicts, no chaos, just the slow, steady progress of objects following the laws of physics, tracing their path through space and time. The fragments of ATLAS are still out there, still moving, still carrying their secrets. They're joined by countless other objects, some natural, some perhaps not, all part of the grand ballet of celestial mechanics. They move in silence, in darkness, mostly unobserved and unremembered. But occasionally one of them catches our attention, sparks our curiosity, and reminds us of how much we don't know. This is the state we find ourselves in now, aware of mysteries but unable to solve them, confronted with questions but lacking definitive answers. It's an uncomfortable position for a species that likes to understand, to categorize, to explain. But it's also an exciting position, a reminder that the universe still has surprises for us, still has stories we haven't heard, still has wonders we haven't imagined. The story of Atlas is one of those wonders. Whether it was a simple comet that happened to behave strangely, or something far more exotic, it has earned its place in the annals of astronomical mysteries. It has become part of the growing catalogue of objects that don't quite fit our expectations, that challenge our assumptions about what's out there in the darkness. As we prepare to explore the deeper implications of these mysteries, to consider what it might mean if objects like ATLAS are more than they appear, we carry with us the image of those fragments spreading through space. Each one is a tiny messenger, a minute piece of a larger puzzle, drifting through the cosmos with patient persistence. They remind us that the universe operates on timescales far beyond human comprehension, that stories begun millions of years ago are still unfolding, that messages sent from distant stars might take eons to arrive. In this cosmic perspective, our brief observation of ATLAS feels both fleeting and profound. We caught a glimpse of something ancient and mysterious as it passed through our neighbourhood. We watched it transform, fragment, and fade. We asked questions that may never be answered, and in doing so, we participated in the grand human tradition of wondering about the lights in the sky, of seeking meaning in the cosmos, trying to understand our place in the vast dark. The brightness that Atlas achieved before its fragmentation was approximately magnitude 8, bright enough to be seen with binoculars, but not quite visible to the naked eye. It's interesting to think about that threshold, that boundary between what we can see with our eyes alone and what requires assistance. Atlas sat right at that edge, almost visible but not quite, like a secret almost revealed but ultimately withheld. Had it continued brightening as predicted, it might have reached magnitude 1 or brighter, making it one of the most prominent objects in the night sky. It would have been visible even from light-polluted cities, a cosmic visitor that everyone could see. Instead, it remained in that liminal space, visible only to those who knew where to look and had the tools to see it. It's as if Atlas chose to remain discreet, to avoid too much attention, to keep its secrets from casual observation. The technical details of its fragmentation are equally intriguing. The breakup began when the comet was about 1.4 astronomical units from the Sun, roughly 130 million miles. That's well outside Earth's orbit, in a region of space where solar heating, while significant, shouldn't typically cause such dramatic disruption. The fragments initially numbered around 5 major pieces, but these continued to subdivide, creating a cloud of smaller and smaller particles. Each fragment behaved slightly differently. Some continued to show cometary activity, developing their own small comae and tails. Others appeared inert, like simple chunks of rock or ice drifting through space. This variation suggests that Atlas wasn't homogeneous, that it contained different materials or structures that responded differently to fragmentation. It's like breaking open a geode and finding complex crystalline structures inside, except in this case, we could only observe from a distance as the pieces drifted apart. The spectroscopic analysis of Atlas before and during its breakup revealed the presence of various molecules common in comets: water, carbon monoxide, cyanide compounds. These are the building blocks of more complex organic chemistry, the kinds of molecules that, under the right conditions, can lead to the formation of amino acids and other prebiotic compounds. Every comet is, in a sense, a delivery system for the raw materials of life, carrying these molecules from the outer reaches of solar systems to the warmer regions where planets might harbour living things. But if Atlas was artificial, these molecules take on a different significance. They could be fuel or coolant for ancient systems. They could be deliberately included to make the object appear natural. They could be the degraded remains of more complex materials, broken down by millions of years of cosmic radiation, or they could be exactly what they appear to be, the natural composition of a comet, with the artificial components being something else entirely, something our instruments couldn't detect. This brings us to an important point about the search for artificial objects in space. We tend to look for things that match our expectations of what technology should look like: metal structures, regular geometries, electromagnetic emissions. But technology advanced enough to send probes between stars might be based on principles we haven't discovered yet. It might use materials we wouldn't recognize as artificial. It might be designed to mimic natural objects so perfectly that only detailed study would reveal their true nature. Consider, for instance, the concept of biomimetic technology, machines designed to imitate biological systems. We're already developing such technologies on Earth, creating robots that move like animals, materials that self-repair like living tissue, systems that adapt and evolve like organisms. An advanced civilization might take this concept to its ultimate conclusion, creating probes that are indistinguishable from natural objects except at the molecular or atomic level. Or consider the possibility of technology so old that it is essentially fossilized. After millions of years in space, exposed to cosmic radiation, micrometeorite impacts, and the slow degradation of materials, even the most obviously artificial object might come to resemble a natural one. The sharp edges would be worn smooth, the surfaces would be covered in dust and ice, the mechanical systems would be frozen and inert. It would be like finding a computer that had been buried in ice for 1,000,000 years. Would we even recognize it as technology? These speculations might seem far-fetched, but they are important to consider as we try to understand objects like ATLAS. If we only look for what we expect to find, we might miss something extraordinary hiding in plain sight. The universe has already surprised us many times, with dark matter, dark energy, quantum mechanics, relativity. Why should we assume that we've exhausted its capacity for surprise? The timing of Atlas's discovery and fragmentation is also worth considering. It arrived just as humanity was becoming capable of detecting and tracking such objects in detail. It performed its strange brightening and fragmentation while we were watching, as if putting on a show for our instruments. And it did all this during a period when we're seriously beginning to contemplate the possibility of interstellar travel ourselves, when projects like Breakthrough Starshot are moving from science fiction to science fact. Is this timing purely coincidental? Almost certainly. The cosmos doesn't arrange itself for our convenience, but it's still remarkable that we're living in the exact era when we can observe these phenomena, when we have the technology to detect interstellar visitors, but haven't yet developed the capability to intercept and study them up close. We're in a unique position, advanced enough to see the mysteries but not advanced enough to solve them. This liminal state, this position between ignorance and understanding, might be exactly where we need to be. If objects like Atlas are natural, we're learning about the diversity and complexity of cometary bodies. If they're artificial, we're being given a gentle introduction to the possibility of extraterrestrial intelligence, a chance to adjust to the idea before more direct contact. Either way, we're being educated, expanded, evolved. The scientific method requires us to default to natural explanations, unless there's compelling evidence for artificial ones. This is appropriate and necessary. Extraordinary claims do indeed require extraordinary evidence, but it's also important to remain open to possibilities, to not dismiss ideas simply because they challenge our assumptions. The history of science is full of discoveries that seemed impossible until they were proven true. As we float here in contemplation, considering these possibilities, we're participating in one of the most profound activities available to conscious beings, the attempt to understand the universe we inhabit. Every question we ask, every mystery we contemplate, every possibility we consider expands our mental horizons. We're like explorers mapping unknown territory, except the territory is conceptual as much as physical, philosophical as much as scientific. The fragments of Atlas continue their journey as we continue ours. They're moving through space. We're moving through ideas. They're following the laws of physics. We're following the paths of logic and imagination. In a sense, we're parallel travelers, each exploring the universe in our own way, each contributing to the slow accumulation of knowledge and mystery that defines our cosmic experience. The dissolution of Atlas, its transformation from a single object to a cloud of fragments, mirrors in some ways the dissolution of our certainties about the universe. Just as the comet came apart, revealing complexity where we expected simplicity, our understanding of the cosmos continues to fragment and reform, showing us new patterns, new possibilities, new questions to pursue. The fragments of Atlas continue their eternal drift through the darkness, each piece now following its own solitary path through the cosmic void. But what if we've been looking at this entire phenomenon through the wrong lens? What if our assumption that comets and asteroids are purely natural objects has blinded us to something far more profound? Let us gently, carefully explore a possibility that might initially seem like science fiction, but becomes increasingly plausible the more we examine the evidence and consider the vast scales of time and space involved. Imagine for a moment that you're not a human on Earth in the 21st century, but rather a member of an ancient civilization that arose somewhere else in our galaxy, millions or even billions of years ago. Your species has solved the problems that currently plague humanity: energy, resources, conflict. You've had not just centuries but millennia to develop your technology, to refine your understanding of physics, to explore your local stellar neighborhood. And now you face the ultimate question that all sufficiently advanced civilizations must confront. Are we alone? The distances between stars are vast, so vast that even at the speed of a light, travel times are measured in years, decades, centuries. Your civilization, patient though it may be, recognizes that sending crewed missions to other star systems is impractical, perhaps impossible. The energy requirements are staggering, the journey times exceed individual lifespans by orders of magnitude, and the risks are incalculable. But there is another way, a way that requires patience rather than power, time rather than energy. You could build probes, not massive, expensive, resource-intensive vessels, but small, efficient, durable machines designed to survive the long dark between stars. These wouldn't need to travel at significant fractions of the speed of light. They could drift, slowly but steadily, carried by the gentle stellar winds and the patient pull of gravity. Given enough time, and the universe has plenty of time, they would eventually reach other star systems, other worlds, other possibilities for life and intelligence. But here's where it gets interesting, where the design philosophy becomes crucial. If you're building something that needs to survive for millions of years in the harsh environment of interstellar space, you wouldn't make it look obviously artificial. Sharp edges collect cosmic dust and create differential stress points. Complex mechanical systems with moving parts are vulnerable to degradation and failure. Electronic circuits are susceptible to radiation damage. No, if you wanted your probe to survive such a journey, you might design it to look like something that already survives such journeys naturally, a comet or asteroid. Think about the elegance of this approach. Comets and asteroids have been travelling through space for billions of years. They've proven their ability to survive the interstellar environment. They're made of materials, ice, rock, dust, that are abundant and stable over cosmic timescales. If you could embed your technology within such a natural-seeming shell, or better yet, if you could create technology that uses these materials as part of its structure and function, you'd have the perfect camouflage and the perfect protection. This brings us back to ATLAS and its peculiar behaviour. The dramatic brightening as it approached our sun could have been more than just ice sublimating. What if it was the activation of systems that had been dormant for millennia? Solar panels, or their equivalent, beginning to collect energy after eons in the dark. Circuits, preserved in the cold of space, warming up and coming back online. Sensors beginning to scan, transmitters preparing to broadcast, mechanisms starting to move after millions of years of stillness. The energy from our sun would be like a gift to such systems, a sudden abundance after an eternity of scarcity. The probe wouldn't need to carry its own power source for the entire journey, an impossibility given the timescales involved. Instead, it could hibernate in the darkness between stars using the absolute cold of space to preserve its components, and then wake up when it detected the warmth and light of a new stellar system. But why would it then fragment? Why would it break apart just as it was entering our solar system? Just as it would have the opportunity to study our planets, our world, perhaps even detect our civilization. This is where the hypothesis becomes even more intriguing. What if the fragmentation wasn't a failure but a feature? What if it was the entire point? Consider the challenges of exploring a solar system with a single probe. You'd have to choose what to study, where to go, what to prioritize. You couldn't be everywhere at once, couldn't observe everything simultaneously. But if your probe could split into multiple components, each capable of independent operation, you could dramatically increase your coverage and your data collection capability. It would be like the difference between having one pair of eyes and having dozens, each looking in a different direction, each gathering different information. The fragments of Atlas, remember, didn't just passively drift apart. Some continue to show activity, brightening and dimming in patterns that puzzled astronomers. They seemed to be doing something, though we couldn't determine what. If these were components of an artificial system, they might have been deploying sensors, releasing smaller probes too tiny for our telescopes to detect, or spreading material designed to be picked up and analysed by any civilization monitoring their skies. There's another possibility too, one that's both beautiful and melancholy. What if the fragmentation was a kind of death, but a planned one? After millions of years in space, after completing its mission of reaching another star system, the probe might have been programmed to disperse, to break apart rather than remain as a single, potentially detectable artifact. It would be the ultimate in non-interference, ensuring that the probe's presence wouldn't significantly affect the system it was studying. This philosophy of non-interference might be crucial for any civilization advanced enough to send interstellar probes. They would understand that their technology, if discovered and misunderstood, could profoundly impact less advanced civilizations. It could cause panic, alter technological development, or fundamentally change a species' understanding of its place in the universe. Better to observe quietly, collect data discreetly, and then fade away, leaving behind only mysteries and questions rather than definitive proof. The materials that make up comets, water ice, carbon compounds, silicates, are not just excellent for surviving interstellar journeys, they're also the building blocks of more complex chemistry. An advanced technology might use these materials not just as camouflage, but as functional components. Water ice could be reaction mass for propulsion. Carbon compounds could be raw materials for self-repair systems. Silicates could form the substrate for computational elements. The entire comet could be both vessel and machine, both protection and probe. We're already beginning to explore such ideas in our own technology. Researchers are developing bio-inspired materials that can self-heal, adapt, and respond to their environment. We're creating computer circuits from organic compounds, building machines that blur the line between living and artificial. An alien civilization with millions of years of technological development might have perfected such approaches, creating probes that are as much organism as machine, as much natural as artificial. The trajectory of ATLAS is worth considering in this context. Interstellar objects don't just randomly encounter star systems. Space is vast and mostly empty, and the chances of a random encounter are infinitesimally small. But if you're deliberately aiming for star systems, if you have even minimal ability to adjust your trajectory over millions of years, you could significantly increase your chances of encounter. A tiny push here, a slight adjustment there, accumulated over eons, could turn a near miss into a direct passage through a stellar system. We detected Atlas when it was already inbound, already on its final approach to the Sun. We don't know where it came from, how long it had been travelling, or whether its trajectory had been adjusted during its journey. But we do know that it passed through our solar system at an interesting time in human development, just as we're beginning to seriously contemplate interstellar travel ourselves. Just as we're developing the technology to detect and track such objects, just as we're starting to listen for signals from other civilizations. Is this timing coincidental? Probably. The universe doesn't arrange itself for our convenience, and the vast majority of events are random rather than purposeful. But it's worth noting that if an alien civilization wanted to observe emerging technological species, sending probes to systems with planets in the habitable zone, and waiting for civilizations to develop would be one way to do it. The probes could lie dormant for millions of years if necessary, patient artificial seeds waiting for the right conditions to germinate. The idea of ancient alien probes isn't new to scientific speculation. In 1960, Ronald Bracewell proposed that advanced civilizations might send autonomous probes to other star systems as a more practical alternative to radio communication. These Bracewell probes would be self-contained, capable of making decisions, and possibly even capable of communication with any civilizations they encountered. They would be like automated ambassadors, carrying information about their creators and gathering information about their discoveries. But Bracewell imagined these probes as obviously artificial, probably metallic, clearly technological. What he perhaps didn't fully consider was how such objects would appear after millions of years in space. The gleaming metal would be pitted and scarred by micrometeorite impacts. Solar wind and cosmic radiation would alter surface chemistry. Dust and ice would accumulate in crevices and on surfaces. After enough time, even the most obviously artificial object might come to resemble a natural one. This is where the concept becomes even more intriguing. What if the disguise isn't just incidental, but intentional? What if these probes are designed to look natural not just after millions of years of degradation, but from the very beginning? It would be the ultimate in camouflage, allowing them to observe without being observed, to study without interfering, to gather information without revealing their presence. The scientific community has generally been skeptical of such ideas, and rightfully so. Science requires evidence, not speculation, and the evidence for artificial interstellar probes is circumstantial at best. But it's worth remembering that absence of evidence is not evidence of absence, especially when we're dealing with technology potentially millions of years more advanced than our own. We might simply not know what to look for, like ancient humans trying to detect radio waves without understanding electromagnetism. The behavior of ATLAS during its fragmentation provides some intriguing data points for this hypothesis. The breakup occurred in stages, with an initial fragmentation followed by further subdivision of the fragments. This cascade pattern is interesting because it's not typical of cometary fragmentation, which usually happens either gradually through erosion or suddenly through explosive outgassing. The Atlas fragmentation seemed almost controlled, as if following a predetermined sequence. Moreover, some of the fragments showed unusual brightness variations after separation. They would flare up and dim in patterns that didn't match what we'd expect from simple, rotating chunks of ice and rock. These variations could be explained by unusual compositions or geometries, but they could also be explained by active systems, perhaps final transmissions, data dumps, or the activation of dispersal mechanisms. The spectroscopic data from ATLAS is also worth reconsidering in this light. We detected typical cometary molecules: water, carbon monoxide, various organic compounds, but spectroscopy can only detect what's on the surface or being actively emitted. If there were artificial components embedded deeper within the structure, protected by layers of natural-seeming material, we wouldn't necessarily detect them. It would be like trying to determine the contents of a house by analysing the composition of its roof. There's a philosophical dimension to this hypothesis that's worth exploring. If alien civilizations are sending probes disguised as natural objects, it suggests something profound about the nature of intelligence in the universe. It suggests civilizations that are curious but cautious, interested in learning about others but careful not to interfere. It suggests a kind of cosmic ethics, a prime directive written not in law but in technology itself. This approach would make sense from a game theory perspective. If you don't know whether other civilizations are friendly or hostile, peaceful or aggressive, the safest strategy is to observe without revealing yourself. You gather information while minimizing risk. You learn about others while keeping your own capabilities and intentions hidden. It's the cosmic equivalent of wildlife photographers using hidden cameras, observing nature without becoming part of the scene. The fragments of ATLAS, if they were artificial, might still be active in ways we can't detect. They might be too small for our telescopes to track, but that doesn't mean they're inert. They could be collecting data about our solar system, analysing the chemical composition of our planet's atmospheres, listening to our radio emissions, observing our technological development. They could be like cosmic dust, seemingly insignificant but actually purposeful, spread throughout our solar system to maximise coverage and minimise detection. Some researchers have suggested that if alien probes exist in our solar system, they might be concentrated in certain locations. The asteroid belt, for instance, would provide excellent camouflage. One more rock among millions. The Lagrange points where gravitational forces balance would be ideal parking spots for long-term observation. The Kuiper belt and Oort cloud in the cold outer reaches of our solar system would be perfect for dormant probes waiting for activation signals. Atlas came from the direction of the constellation Ursa Major, though its ultimate origin was certainly much more distant. If we trace its trajectory backward, accounting for the gravitational influences of stars it might have passed, we find that it could have originated from almost anywhere in our galaxy. It might have been travelling for millions of years, perhaps billions, its craters long since evolved beyond recognition or extinct entirely. This raises another fascinating possibility. What if Atlas wasn't sent by a current civilization but by one that no longer exists? What if it's a relic from the deep past, a message from a species that flourished when our sun was young, or perhaps not even formed yet? It would be like finding a fossil, except instead of preserved bones or shells, we'd be looking at preserved technology, preserved intentions, preserved curiosity about the universe. The lifespan of civilizations is unknown. We have only one example, our own, and we've only been technological for a tiny fraction of cosmic time. But if we consider the possible trajectories of advanced civilizations, several possibilities emerge. They might destroy themselves through war or environmental catastrophe. They might transcend physical existence, uploading their consciousness into virtual realities or evolving into something we wouldn't recognize as life. They might simply age out, losing interest in exploration and expansion, turning inward rather than outward. But their probes, their mechanical descendants, might outlive them by millions or billions of years. These artifacts would continue their programmed missions long after their creators were gone, like dutiful servants maintaining an empty house. They would be the only evidence that these civilizations ever existed, silent testaments to ancient curiosity and ingenuity. Atlas, in this context, becomes almost poignant. If it was artificial, it might be an orphan, a technological orphan from a civilization that no longer exists to receive its data or appreciate its discoveries. Its fragmentation might have been its final act, the completion of a mission assigned so long ago that the very stars have shifted position since it began. The way Atlas brightened before fragmenting could be interpreted as a kind of awakening. Imagine systems that have been dormant for eons suddenly receiving energy from our sun. Circuits that have been preserved in the absolute cold of interstellar space beginning to warm up. Memory banks accessing data stored since before our species evolved. Sensors calibrating themselves using our sun's spectrum. It would be like watching something come alive, except the something would be older than our world. But then, having awakened, having perhaps completed whatever observations or analyses it was programmed to perform, it dispersed. Not violently, not catastrophically, but gently, almost peacefully, like a dandelion releasing its seeds, or like a dying organism releasing spores to continue its genetic legacy, each fragment carrying part of the whole, each continuing the journey in its own way. The scientific instruments we used to observe ATLAS were impressive by human standards. Ground-based telescopes with adaptive optics, space-based observatories above our atmosphere, spectrographs that can tease apart the chemical signatures of distant objects. But compared to what an advanced civilization might deploy, our instruments are primitive. We might be trying to understand advanced technology with tools barely capable of detecting its presence, like trying to understand a symphony by feeling the vibrations through the floor. This limitation in our observational capabilities means that even if Atlas was artificial, we might never have been able to prove it definitively. The evidence would be subtle, ambiguous, open to interpretation, which might be exactly the point. A truly advanced probe would be designed to maintain plausible deniability, to always leave room for natural explanations, to never provide conclusive proof of its artificial nature. The chemistry of comets provides an interesting angle on this hypothesis. Comets contain complex organic molecules, amino acids, sugars, phosphates. These are the building blocks of life as we know it. Some scientists have suggested that comets might have delivered these crucial ingredients to early Earth, seeding our planet with the materials necessary for life to emerge. But what if this process isn't entirely random? What if some comets are deliberately designed to carry and deliver such materials? This concept, sometimes called directed panspermia, was proposed by Francis Crick, co-discoverer of DNA structure. He suggested that life on Earth might have been deliberately seeded by an alien civilization. While this remains highly speculative, it's not entirely implausible. If a civilization wanted to spread life throughout the galaxy, sending out probes carrying microorganisms or the chemical precursors of life would be more practical than trying to colonize planets directly. Atlas, with its rich chemistry and its fragmentation in our inner solar system, could hypothetically have been performing such a function. Its fragments, too small for us to track, might have carried more than just ice and rock. They might have carried information encoded at the molecular level, or microorganisms designed to survive the journey through space, or chemical catalysts that could influence the development of life on suitable worlds. The timing of Atlas's appearance in our solar system is intriguing when considered against the backdrop of Earth's history. We are living in a unique moment, the only known planet with life, in the only known solar system with a technological civilization, at the exact time when we're capable of detecting and studying objects like ATLAS. In the 4.5 billion year history of our solar system, the window during which we could observe and contemplate such objects is vanishingly small, perhaps a few hundred years out of billions. Yet here we are, and here was Atlas, crossing paths at this precise moment. The odds of such a coincidence are astronomical, unless such encounters are far more common than we realize, or unless there's some element of purposefulness to the timing. Perhaps probes like ATLAS are constantly passing through our solar system, and we're only now becoming aware of them. Or perhaps they're attracted to certain signatures, radio emissions, atmospheric changes, the spectroscopic evidence of industrial activity, that indicate the presence of a technological civilization. The way Atlas fragmented, spreading its material across a wide area, resemble strategies we use in our own space missions. When we want to study a planet or moon, we often deploy multiple instruments, sometimes releasing smaller probes or landers from a main spacecraft. The Cassini mission to Saturn released the Huygens probe to land on Titan. The Mars rovers were delivered by larger spacecraft that remained in orbit or flew by. It's a proven strategy for maximizing scientific return from a single mission. If Atlas was employing a similar strategy, its fragments might have had different purposes, different destinations, different missions. Some might have been aimed at the inner planets, others at the outer system. Some might have been designed to collect data, others to deliver payloads. The apparent randomness of the fragmentation might actually have been a carefully orchestrated dispersal pattern, optimized for coverage and efficiency. The fragments that showed continued activity after separation are particularly interesting. These pieces seem to have their own energy sources, their own volatile materials that continue to sublimate even after breaking away from the main body. This could be explained by the exposure of fresh ice previously protected inside the comet, but it could also be explained by the activation of independent systems, each fragment functioning as an autonomous unit once separated from the whole. We've lost track of most of Atlas's fragments now, They've become too faint to observe, too small to track, dispersed across too wide an area to monitor. But they're still out there, still moving through our solar system, still carrying whatever secrets they've always carried. Some might eventually impact planets or moons, delivering their payload directly. Others might escape back into interstellar space, continuing their eternal journey. And some might still be here, dark and silent, waiting. The concept of waiting is important when considering artificial probes. If you're designing something to operate over millions of years, patience would be a core feature. The probe wouldn't need to accomplish its mission quickly. It could wait for optimal conditions, wait for the right moment, wait for certain triggers or thresholds to be met. Atlas might have been waiting in the outer solar system for years, decades, even centuries before beginning its inward journey. And its fragments might still be waiting, watching, recording. The scientific method requires us to favour natural explanations over artificial ones, unless there's compelling evidence otherwise. This is appropriate and necessary. We shouldn't jump to extraordinary conclusions based on limited data. But we also shouldn't dismiss possibilities simply because they seem unlikely, or challenge our assumptions. The universe has surprised us before, and will undoubtedly surprise us again. The mystery of Atlas adds to a growing collection of anomalies and puzzles that suggest our understanding of comets and asteroids might be incomplete. Objects like Oumuamua with its unusual acceleration, asteroids with impossible orbits, comets that behave in unexpected ways. Each of these challenges our models and expands our awareness of what's possible. Even if they're all entirely natural, they're teaching us that nature is more creative, more diverse, more surprising than we imagined. But what if some of them aren't natural? What if we're looking at a mixture of natural objects and artificial ones, so well disguised that we can't tell them apart? It would mean that we're not alone, that intelligence has arisen elsewhere and has found ways to explore the galaxy that we're only beginning to imagine. It would mean that the cosmos is not just full of rocks and ice, but also of purpose and intention, of curiosity and design. The search for extraterrestrial intelligence has traditionally focused on radio signals, on the assumption that advanced civilizations would communicate using electromagnetic radiation. But what if physical artifacts are a more reliable method of contact? Radio signals weaken with distance, can be disrupted by interference, and require precise timing to detect. But a physical probe can carry its message across any distance, preserve it for any length of time, and deliver it directly to its destination. Atlas might have been such a message, written not in radio waves but in matter itself, its composition, its behaviour, its fragmentation pattern. All of these could be parts of a communication we don't yet know how to read. We're like archaeologists finding an artifact from an unknown civilization, turning it over in our hands, trying to understand what it means, what it's for, who made it, and why. The fact that we can't definitively determine whether Atlas was natural or artificial is itself significant. It shows us the limits of our current understanding and technology. It reminds us that there are questions we can ask but not yet answer, mysteries we can observe but not yet solve. This state of uncertainty, of not knowing, is actually valuable. It keeps us curious, keeps us searching, keeps us open to possibilities. As we continue to monitor the skies, as our instruments become more sensitive and our understanding deepens, we might find more objects like ATLAS. We might begin to see patterns, to recognize signatures, to develop ways of distinguishing natural from artificial. Or we might discover that the distinction itself is flawed, that sufficiently advanced technology becomes indistinguishable from nature, that the universe is stranger and more wonderful than we currently imagine. The story of ATLAS is still being written. Its fragments continue their journeys, carrying their secrets through the darkness. The data we collected during its brief visibility is still being analysed, still yielding insights and raising questions. And somewhere out there, perhaps, other objects like Atlas are approaching, carrying their own mysteries, their own stories, their own possibilities. In contemplating these possibilities, we're engaging in one of the most profound acts of imagination available to conscious beings. We're trying to think beyond our own experience, beyond our own assumptions, beyond our own limitations. We're trying to imagine minds unlike our own, technologies we haven't invented, purposes we haven't conceived. It's an exercise in humility and wonder, in recognizing that we are not the measure of all things, that the universe might contain wonders we're not yet equipped to recognize or understand. The hypothesis that Atlas might have been artificial remains unproven, and perhaps unprovable. But the value of the hypothesis isn't in its truth or falsehood, it's in the questions it raises, the possibilities it opens, the expansion of our thinking it requires. Even if Atlas was entirely natural, considering the alternative helps us understand what we should be looking for, what signatures might indicate artificial origin, what technologies might be possible. As we drift deeper into this contemplation, we can appreciate the profound implications of either possibility. If Atlas was natural, it shows us that comets can behave in ways we don't yet understand, that there are processes and mechanisms we haven't discovered, that nature still has surprises for us. If it was artificial, it means we've been visited by technology from another world, observed by intelligence from another star, touched however briefly by the curiosity of another species trying to understand the universe just as we are. Either possibility brings us face to face with one of the most profound questions humanity has ever asked. Are we alone in the universe? This question, simple in its formulation but staggering in its implications, has haunted our species since we first looked up at the stars and recognized them as distant suns. The appearance of objects like Atlas and Oumuamua doesn't answer this question definitively, but it does add new dimensions to our contemplation of it, new ways of thinking about what contact with other intelligence might look like, and new perspectives on the vast silences that seem to surround us in the cosmos. The physicist Enrico Fermi famously posed what has become known as the Fermi paradox during a casual lunch conversation in 1950. The paradox is simple. Given the vast number of stars in our galaxy, the billions of years available for life to develop, and the relative ease with which an advanced civilization could colonize the entire galaxy, where is everybody? Why don't we see obvious signs of extraterrestrial civilizations? Why does the universe seem so quiet, so empty of the radio chatter and megastructures we might expect from species billions or billions of years more advanced than ourselves? The traditional answers to Fermi's question have ranged from the pessimistic to the transcendent. Perhaps life is extraordinarily rare, and we really are alone or nearly alone in the galaxy. Perhaps intelligence is the rare step, with countless worlds teeming with bacteria, but few developing conscious tool-using species. Perhaps technological civilizations inevitably destroy themselves, falling victim to nuclear war, environmental collapse, or dangers we haven't yet imagined. Or perhaps advanced civilizations evolve beyond physical existence, disappearing into virtual realities or ascending to dimensions we cannot perceive. But what if the answer is simpler and more subtle? What if the universe isn't silent at all, but rather filled with whispers we're only now learning to hear? What if the evidence of other civilizations isn't in loud radio broadcasts or massive engineering projects, but in quiet visitors like ATLAS, in gentle probes that observe without interfering, in artifacts designed to be noticed only by species that have reached a certain level of technological sophistication? This possibility transforms the Fermi paradox from a puzzle about absence into a challenge of perception. We've been looking for civilizations that behave like we imagine we would behave, broadcasting our presence, building massive structures, visibly transforming our environment. But perhaps mature civilizations are more subtle, more careful, more respectful of the cosmic environment. Perhaps they've learned lessons we haven't yet learned about the importance of quiet observation, of minimal interference, of allowing other species to develop naturally without contamination from outside influences. Consider the perspective of a civilization that has survived for millions of years. They would have weathered whatever crises threaten young technological species. They would have solved their energy needs, managed their resources, found sustainable ways of existing. Such a civilization might view the galaxy very differently than we do. Where we see empty space to be conquered and colonized, they might see a garden to be tended and observed. Where we imagine expansion and exploitation, they might practice preservation and study. The sending of camouflage probes like Atlas might hypothetically could be part of a galactic survey system, a way of monitoring the development of life and intelligence throughout the galaxy without interfering with it. These probes would be like cosmic census takers, quietly noting which systems have planets, which planets have life, which life has developed intelligence, which intelligence has developed technology. The information gathered wouldn't be for conquest or contact, but simply for knowledge, for understanding the patterns and processes of cosmic evolution. This kind of quiet observation would actually be a sign of ethical sophistication. On Earth, we've learned through bitter experience that when technologically advanced cultures encounter less advanced ones, the results are often catastrophic for the less advanced. Disease, cultural disruption, economic exploitation, and outright conquest have marked most such encounters in human history. And truly advanced civilization would understand these dangers and take steps to avoid them, observing from a distance rather than making direct contact. The fragments of ATLAS dispersed through our solar system could be thought of as seeds of observation, each one a tiny sensor gathering data about our local environment. They wouldn't need to be sophisticated by the standards of their creators. Even simple measurements of temperature, radiation, magnetic fields, and chemical composition would provide valuable data when aggregated across millions of such probes throughout the galaxy. It would be like having a vast network of weather stations, but instead of monitoring atmospheric conditions, they'd be monitoring the conditions for life and intelligence. The timing of our detection of interstellar objects is worth contemplating in this context. We've only had the capability to detect and track such objects for a few decades. In that incredibly brief time, we've already found several objects with unusual properties that have challenged our understanding. If interstellar visitors are this common, if we're finding them this frequently just as we develop the ability to see them, it suggests that our solar system has been experiencing such visits throughout its history. We're not seeing an increase in visitors, we're experiencing an increase in our ability to perceive them. This realization should be both humbling and exciting. Humbling because it suggests we've been oblivious to cosmic traffic passing through our neighborhood for billions of years. Exciting because it means there's so much more to discover, so many more mysteries to uncover, so many more opportunities to learn about our cosmic context. Every improvement in our detection capabilities might reveal new categories of objects, new types of visitors, new pieces of the vast puzzle that is our universe. The great silence that Fermi wondered about might not be a silence at all, but rather a conversation conducted in languages we don't yet speak, using methods we don't yet recognize. Physical artifacts like Atlas might be one form of communication. Subtle alterations to stellar spectra might be another. Patterns in the distribution of asteroids, the composition of comets, the timing of supernovae. Any or all of these could hypothetically carry information, messages, or simply evidence of intelligence at work. We're like children who have just learned that the marks on paper can carry meaning, but haven't yet learned to read. We see the marks, the unusual objects, the strange behaviors, the statistical anomalies, but we don't yet know if they're meaningful or random, intentional or natural. Learning to read these potential messages, to distinguish signal from noise, intention from coincidence, will be the work of generations, perhaps centuries. The possibility that we're surrounded by gentle whispers rather than loud broadcasts also suggests something about the nature of intelligence in the universe. Perhaps the urge to shout, to announce oneself loudly, is a phase that civilizations pass through quickly. Like teenagers with their first car radio, young civilizations might broadcast loudly for a brief time before learning the value of quiet observation. The cosmic radio silence we observe might not indicate absence but maturity, not emptiness but discretion. Atlas, viewed through this lens, becomes part of a much larger pattern. It's not just a single mysterious object, but potentially one example of a vast, quiet migration of intelligence throughout the galaxy. These migrations wouldn't be invasions or colonizations, but something more like the movement of ideas, the slow spread of awareness and observation throughout the cosmic community. Each probe would be a neuron in a vast galactic nervous system, gathering sensory data about the state of the galaxy and its inhabitants. The fragmentation of ATLAS takes on new meaning in this context. If it was artificial, its dissolution might have been a kind of death, but death in service of a larger purpose. Like a cell dividing, or a plant releasing seeds, the fragmentation could have been a form of reproduction or dispersal, ensuring that the mission continues even as the original structure ceases to exist. The fragments, each carrying part of the original's purpose and programming, would continue the work on a smaller, more distributed scale. This kind of distributed intelligence, spread across millions or billions of small probes throughout the galaxy, would be remarkably robust. The loss of any individual probe, or even millions of probes, wouldn't significantly impact the overall system. It would be like the internet, where the loss of individual nodes doesn't compromise the network as a whole. Such a system could operate for geological timescales, surviving the death of stars, the collision of galaxies, the vast changes that occur over billions of years. We humans are just beginning to experiment with distributed systems, swarm intelligence, and networked sensors. Our early attempts are primitive compared to what we're imagining here, but they give us a glimpse of what's possible. Imagine scaling up our current technology by millions of years of development. Imagine probes that can repair themselves, replicate themselves, evolve and adapt to new conditions. Imagine a galactic nervous system that has been growing and developing since before our sun was born. The universe we're contemplating now is very different from the empty, silent cosmos that the Fermi paradox seems to suggest. Instead of a vast emptiness punctuated by rare islands of intelligence, we're imagining an ocean of awareness, a cosmos permeated by observation and intention, a galaxy where intelligence is not rare but ubiquitous, not loud but quiet, not absent but simply unrecognized. This vision has profound implications for our future as a species. If we are indeed surrounded by mature intelligences practicing cosmic discretion, our own development is being watched, noted, perhaps even gently influenced. We're like children, playing in a playground, thinking we're alone, while actually being watched by patient adults who remember their own childhood and understand the importance of letting us learn our own lessons. The challenges we face as a species, climate change, nuclear weapons, artificial intelligence, biotechnology, might be common to all developing civilizations. The quiet observers, if they exist, would have faced similar challenges and either overcome them or perished. They would know that these challenges are necessary passages, tests that determine whether a species is ready for the larger cosmic community or destined to remain forever isolated by its own limitations. Atlas and objects like it might be monitoring our progress through these challenges, not to judge or interfere, but simply to observe, to add our story to the vast collection of stories that make up the history of intelligence in the galaxy. We're writing our chapter in this cosmic book, and every decision we make, every crisis we navigate or fail to navigate, becomes part of the permanent record. This perspective should inspire both caution and hope. Caution, because our actions have cosmic significance, because we're potentially being observed and evaluated by intelligences far beyond our current understanding. Hope, because the existence of such observers would mean that the challenges we face can be overcome, that it's possible for technological civilizations to survive their dangerous youth and mature into something sustainable and magnificent. The search for extraterrestrial intelligence has traditionally focused on finding others like us, young, loud, technological civilizations broadcasting their presence to the cosmos. But perhaps we should also be looking for evidence of mature intelligences, for the subtle signs of cosmic gardeners tending their galaxy, for the quiet whispers of ancient observers who have learned the value of silence and patience. The chemistry of objects like ATLAS provides another avenue for contemplation. Comets are known to contain organic molecules, the building blocks of life as we know it. Some scientists have proposed that comets might have delivered these crucial ingredients to early Earth, kick-starting the chemical evolution that eventually led to life. But what if this process isn't entirely random? What if some comets are deliberately enriched with organic molecules, designed to seed suitable planets with the ingredients for life? This concept, known as directed panspermia, was first seriously proposed by Francis Crick and Leslie Orgel in 1973. They suggested that life on Earth might have been deliberately seeded by an alien civilization, either as a kind of cosmic gardening project or as a way to preserve and spread life throughout the galaxy. While this remains highly speculative, it's not entirely implausible given what we know about the hardiness of certain microorganisms and the protective environment that a comet's interior could provide during interstellar travel. Atlas, with its rich chemistry and its fragmentation in our inner solar system, could hypothetically have been performing such a function. Its fragments, now dispersed throughout our solar system, might be carrying more than just ice and rock. They might be carrying the seeds of life, or the catalyst for life's development, or information encoded at the molecular level that could influence the evolution of any life they encounter. This possibility adds another layer to our contemplation of cosmic intelligence. Life itself might be a message, a communication medium used by ancient civilizations to spread not just information, but actual living processes throughout the galaxy. DNA, with its ability to store vast amounts of information in a tiny space, its self-replicating properties, and its ability to evolve and adapt, might be the ultimate communication technology, a way of sending messages that can survive for billions of years and adapt to local conditions. If this is true, then we ourselves might be messages, or at least the descendants of messages, sent by intelligences so ancient that they predate our solar system. The very molecules that make up our bodies, the genetic code that defines our biology, the consciousness that allows us to contemplate these possibilities, all of these might be part of a vast, slow, biological communication system operating on timescales we can barely imagine. The universe we're envisioning now is not just filled with intelligence, but with purpose, not just with observers, but with gardeners, not just with messages, but with life itself as a medium of communication. It's a cosmos where the boundaries between natural and artificial, between evolved and designed, between message and messenger, become blurred and perhaps ultimately meaningless. Atlas, where the natural or artificial reminds us of our cosmic context. We're not isolated on our small planet, separate from the rest of the universe. We're part of a vast interconnected system, where objects from distant stars routinely pass through our neighborhood, where the chemistry of life is common throughout the cosmos, where the possibilities for intelligence and awareness extend far beyond our current understanding. The night sky, viewed with this perspective, becomes not a cold and empty void, but a vast ocean of possibility. Every point of light might harbour life or intelligence. Every dark space might hide visitors like Atlas, quiet observers on million-year journeys. Every meteor might carry messages we don't yet know how to read. We're surrounded by mysteries, immersed in wonders, participating in a cosmic story whose beginning we don't know and whose end we can't imagine. As we contemplate these possibilities, drifting through ideas as Atlas drifted through space, we can appreciate the profound privilege of consciousness, of being able to wonder about our place in the universe, of being able to ask questions even when we don't have answers, with the universe becoming aware of itself, matter organized in such a way that it can contemplate its own existence and origin. The mystery of a TLS adds to this contemplation, providing a concrete example of how much we don't know, how much there is still to discover. Every anomaly, every unusual observation, every object that doesn't quite fit our models is an opportunity to expand our understanding, to refine our theories, to grow in our appreciation of cosmic complexity and beauty. The fact that we may never know for certain whether Atlas was natural or artificial is itself a valuable lesson. It reminds us that the universe doesn't owe us certainty, that some mysteries may remain forever unsolved, that the journey of discovery is more important than the destination of complete knowledge. We're explorers in an infinite territory, and there will always be new frontiers, new questions, new wonders to contemplate. As the fragments of Atlas continue their separate journeys through the darkness, they carry with them not just their physical substance, but also the questions they've raised, the possibilities they've suggested, the expansion of imagination they've triggered. They're like seeds of wonder, planted in the minds of all who have learned about them, growing into new thoughts, new theories, new ways of understanding our cosmic situation. The universe revealed by modern astronomy is far stranger than our ancestors could have imagined. It's filled with dark matter we can't see, dark energy we don't understand, black holes that warp space and time, quantum phenomena that defy common sense. Adding the possibility of camouflaged alien probes to this list doesn't make the universe significantly stranger. It's already strange beyond comprehension. But it does make it more interesting, more filled with potential for discovery and contact. We live in an age of cosmic revelation, where new discoveries regularly overturn old assumptions, where the impossible becomes possible, where the universe reveals itself to be far more creative and complex than we imagined. Atlas is part of this revelation, a small piece of a vast puzzle we're only beginning to assemble. Whether it was a simple comet or something more exotic, it has served its purpose in expanding our awareness, challenging our assumptions, and inspiring our imagination. The search for meaning in the cosmos is perhaps the most human of all endeavours. We're pattern-seeking creatures, storytelling beings, consciousness that craves understanding and connection. When we look at objects like Atlas, we're not just seeing ice and rock, trajectories and chemistry. We're seeing possibilities, stories, connections to something larger than ourselves. We're seeing evidence that we're part of a cosmic community, even if we don't yet know the other members. This search for cosmic meaning isn't separate from science. It's the motivation that drives science forward. Every astronomer scanning the skies, every researcher analysing data, every theorist proposing new models is participating in humanity's attempt to understand its cosmic context. We're collectively writing the story of the universe, or at least our chapter of it, one observation at a time, one discovery at a time, one mystery at a time. Atlas has become part of this story, a character whose role we don't fully understand, but whose presence has enriched the narrative. It appeared briefly on our cosmic stage, performed its mysterious act, and then dissolved into fragments too small to follow. But the questions it raised remain, continuing to influence our thinking about what might be out there in the darkness, what might be possible, what we might discover as our capabilities and understanding grow. The possibility that we're living in a universe filled with ancient artifacts, quiet observers, and gentle whispers of intelligence should inspire us to look more carefully, to listen more attentively, to remain open to possibilities we haven't yet imagined. Every improvement in our technology, every new telescope, every more sensitive instrument might reveal new categories of mystery, new types of cosmic visitor, new evidence that we're not alone. But even if we are alone, even if Atlas was just a comet and nothing more, the universe revealed by its study is still magnificent. A cosmos where chunks of primordial ice can travel for millions of years between stars, where the building blocks of life are common, where objects can behave in ways that surprise and puzzle us, This is a universe worthy of wonder, deserving of study, demanding of our attention and appreciation. As we approach the end of our contemplation of Atlas, we're not reaching conclusions, but rather appreciating the questions. The mystery remains unsolved, and perhaps that's as it should be. Some questions are more valuable than their answers, some mysteries more important than their solutions. The question, what if Atlas was built, not born, has taken us on a journey through possibilities, through different ways of thinking about intelligence and technology, through new perspectives on our cosmic situation. This journey doesn't end with the last fragment of ATLAS disappearing into the darkness. It continues every time we look up at the night sky and wonder what's out there. It continues with every new discovery, every anomalous observation, every object that doesn't quite fit our expectations. It continues as we develop new technologies, new ways of seeing and understanding the universe. And it continues in the minds of everyone who has heard this story, wondered about these possibilities, and expanded their sense of what might be possible in our vast and mysterious cosmos. The fragments of ATLAS are still out there, somewhere in the darkness, continuing their eternal journey. Most are probably heading back into interstellar space, returning to the void from which they came, but some might remain in our solar system, orbiting quietly, waiting to be rediscovered by future generations with better instruments and deeper understanding. They're like time capsules, preserving their secrets for those who come after us, those who might have the tools and knowledge to finally understand what Atlas was and what it meant. Future astronomers might look back at our observations of ATLAS with the same mixture of respect and amusement that we feel when reading about early astronomers trying to understand comets as atmospheric phenomena or celestial omens. They might have answers to the questions we can only pose, solutions to mysteries we can only contemplate. Or they might have even bigger questions, even deeper mysteries, making our puzzlement over Atlas seem quaint by comparison. This is the nature of scientific progress. Each generation builds on the observations and questions of those who came before, approaching closer to understanding but never quite reaching complete knowledge. The universe is too vast, too complex, too creative for any single species or civilization to fully comprehend. But in the attempt, in the reaching toward understanding, we find meaning and purpose, connection, and wonder. Atlas has contributed to this grand endeavour simply by existing, by passing through our awareness, by refusing to fit neatly into our categories and expectations. It has reminded us that there's still so much to learn, so much to discover, so much to wonder about, in a world that can sometimes seem fully explored, fully understood, fully demystified. Atlas brings back the mystery, the unknown, the sense of cosmic adventure that has driven human curiosity since we first looked up at the stars. As we settle deeper into this contemplation, feeling the vast scales of space and time that Atlas has travelled through, we can appreciate our unique position as conscious observers in an apparently unconscious cosmos, or perhaps not so unconscious. If Atlas was artificial, if the universe is filled with quiet intelligence, then consciousness might be as fundamental to the cosmos as matter and energy, space and time. We're participants in a cosmic story that began billions of years before we existed and will continue billions of years after we're gone. Atlas is part of that story. We're part of that story. And the interaction between us, brief and puzzling as it was, is part of that story. We've added our observations to the permanent record, our questions to the eternal conversation, our wonder to the accumulated wonder of all conscious beings who have ever contemplated the cosmos. The universe doesn't need us to understand it in order to exist, but perhaps it needs us to understand it in order to be complete. Perhaps consciousness, awareness, the ability to observe and question and wonder, is what transforms the universe from a mere collection of matter and energy into something meaningful, something beautiful, something worthy of existence. And perhaps objects like ATLAS, whether natural or artificial, are part of the process by which the universe comes to know itself, to appreciate itself, to wonder at itself. As we near the end of our journey with Atlas, we can reflect on how a simple astronomical observation, a faint smudge of light detected by an automated telescope, has led us through such vast territories of thought and possibility. We've contemplated ancient civilizations and their potential artifacts, the nature of intelligence and technology, the possibilities for life and consciousness in the cosmos, and our own place in the grand scheme of existence. This is the power of mystery, the value of the unknown. It expands our thinking, challenges our assumptions, and inspires our imagination. Atlas, in its brief appearance and mysterious behaviour, has given us a gift, not answers, but better questions, not certainty, but wonder, not conclusions, but possibilities. It has reminded us that the universe is not a solved problem but an ongoing revelation, not a static stage but a dynamic story still being written. The night sky will never look quite the same after contemplating ATLAS. Every meteor might be a fragment of something larger and more mysterious. Every comet might be more than it appears. Every point of light might represent not just a star but a home to intelligence we can't yet recognize or understand. The darkness between the stars, rather than being empty, might be filled with quiet travelers like Atlas, carrying their secrets through eternity. This expanded awareness, this cosmic perspective, is perhaps the greatest gift of astronomy. It lifts us out of our provincial concerns, our temporary troubles, our limited viewpoints, and shows us something infinitely larger, older, and more wonderful. It doesn't diminish us, but rather elevates us, making us part of something magnificent, something meaningful, something that transcends our individual existence while including it. Atlas, whether it was a simple comet or something far more exotic, has contributed to this gift. It has added its small part to the vast accumulation of human knowledge and wonder about the cosmos. It has become part of our story, our attempt to understand where we are, and what else might be out there in the vast dark. And in becoming part of our story, it has ensured that its journey, mysterious as it was not in vain. The fragments continue their journey as we continue ours. They move through space, we move through understanding. They carry their physical substance. We carry the memory and meaning of their passage. They're heading into the unknown. So are we. In this parallel journey, this cosmic companionship, there's a kind of beauty, a sense of shared adventure, a recognition that we're all humans and comets, natural objects and potential artifacts, part of the same vast unfolding story. As we prepare to conclude our contemplation of ATLAS, we return to the central question that has guided our journey. What if it was built, not born? We don't have a definitive answer, and perhaps we never will. But in exploring the question, in considering the possibilities, in expanding our imagination to encompass artificial comets and ancient probes, we've enriched our understanding of what might be possible in our universe. The question itself is more valuable than any answer could be. It keeps us curious, keeps us searching, keeps us open to possibilities we haven't yet imagined. It reminds us that the universe is not fully known, that there are still mysteries to solve, wonders to discover, surprises waiting in the darkness. It connects us to the grand tradition of human inquiry, the endless quest to understand our cosmic context. Atlas has joined the pantheon of cosmic mysteries that define our era. Dark matter, dark energy, the nature of consciousness, the origin of life, the possibility of other intelligence. These mysteries are not problems to be solved quickly, but rather deep questions that will occupy humanity for generations, perhaps forever. They're the driving force of our intellectual and spiritual development, the challenges that push us to grow, to evolve, to become more than we currently are. In the end, the story of ATLAS is not really about a comet, whether natural or artificial. It's about us, our capacity for wonder, our drive to understand, our place in a cosmos far stranger and more wonderful than we imagined. It's about the questions we ask when confronted with mystery, the possibilities we imagine when faced with the unknown, the growth we experience when our assumptions are challenged. Every person who has learned about Atlas, wondered about its nature, and contemplated its implications has become part of its extended story. The comet may have fragmented and dispersed, but the ideas it sparked, the questions it raised, the wonder it inspired continue to propagate through human consciousness like waves spreading across a cosmic pond. In this way, Atlas achieves a kind of immortality, living on not in its physical form but in its impact on thought and imagination. The universe we inhabit is vast beyond comprehension, old beyond measure, and strange beyond imagination. But it's not beyond questioning, beyond wondering about, beyond attempting to understand. Every mystery we encounter, every anomaly we observe, every object like Atlas that doesn't quite fit our expectations is an invitation to grow, to learn, to expand our awareness of what's possible. As we float here in the darkness of contemplation, surrounded by the vast mysteries of the cosmos, we can appreciate the profound beauty of our situation. We're conscious matter contemplating unconscious matter, or perhaps conscious matter contemplating other conscious matter we don't yet recognize. We're the universe investigating itself, questioning itself, wondering about itself. We're participants in a cosmic detective story, where we're simultaneously the detectives, the witnesses, and part of the mystery itself. Atlas has played its role in this story and departed, leaving us with more questions than answers, more wonder than certainty, more possibilities than conclusions. But that's exactly as it should be. The universe doesn't owe us easy answers or complete understanding. It offers us instead something far more valuable: endless mystery, infinite possibility, eternal wonder. The journey we've taken with Atlas, from its discovery through its strange brightening, its mysterious fragmentation, and its dissolution into untrackable fragments, has been more than just an astronomical observation. It's been a meditation on possibility, an exploration of what might be, a gentle expansion of our cosmic awareness. We've used Atlas as a lens through which to examine bigger questions about intelligence, technology, and our place in the universe. These questions don't have easy answers, and perhaps they don't have answers at all in any final sense, but they have value beyond answers. They keep us growing, keep us searching, keep us humble in the face of cosmic mystery, while proud of our ability to recognize and contemplate that mystery. They make us human in the deepest sense, creatures capable of wonder, capable of imagining what we can't prove, capable of seeing meaning in the movements of ice and rock through the darkness. As our contemplation draws toward its close, we can feel the weight and beauty of cosmic time, the vast scales on which the universe operates, the patience required for stories that unfold over millions of years. Atlas travelled for eons to reach us, spent a few months in our awareness, and then continued on its way, transformed but not destroyed, dispersed but not disappeared. Its story intersected briefly with ours, creating this moment of wonder and speculation that we've shared. In years to come, decades, centuries, we may discover what ATLAS really was. New technologies might allow us to detect and analyze similar objects in greater detail. We might find patterns that reveal whether such objects are natural or artificial. We might even recover some of Atlas's fragments and study them directly. Or we might never know, and Atlas will remain forever a mystery, a question mark in the annals of astronomy, a reminder that the universe still holds secrets. Either outcome is acceptable, even beautiful in its own way. Discovery and mystery are both part of the human experience, both necessary for our continued growth and development. We need answers to build our understanding, but we need questions to drive our curiosity. We need certainty to stand on, but we need uncertainty to reach toward. Atlas has provided us with a perfect balance of both, enough observation to spark serious speculation, but not enough to reach definitive conclusions. The cosmos continues its patient unfolding around us, indifferent to our curiosity but generous with its mysteries. New objects are approaching our solar system even now, carrying their own secrets, their own stories, their own potential for wonder and discovery. Some will detect and study, adding to our growing catalogue of cosmic phenomena. Others will pass by unnoticed, their stories untold, their mysteries preserved for future generations with better tools and deeper understanding. Atlas was one of the ones we noticed, one of the ones that captured our attention and imagination. In the vast cosmic lottery of astronomical observation, we won a small prize. Not understanding, but wonder. Not answers, but better questions. And perhaps that's the greatest prize of all, the one that keeps us looking up at the night sky, keeps us building better telescopes, keeps us reaching toward the stars with our minds, if not yet with our bodies. The final fragments of Atlas are too small to track now, but they continue their journey through the darkness. Each one carries a piece of the original mystery, a fragment of the questions we've been contemplating. They're like seeds of wonder scattered through the solar system and beyond, each one a potential future discovery, a possible revelation waiting for the right moment, the right observer, the right technology to unlock its secrets. We began this journey with a simple question: what if Atlas was built, not born? We've explored this possibility from multiple angles, considered its implications, contemplated what it might mean for our understanding of the universe and our place in it. We haven't answered the question definitively. We can't with our current knowledge and capabilities. But we've done something perhaps more valuable. We've expanded our sense of possibility, enriched our cosmic imagination, and deepened our appreciation for the mysteries that surround us. The universe revealed through our contemplation of Atlas is not empty but full, not silent but whispering, not indifferent but perhaps watching. It's a cosmos where intelligence might take forms we don't recognize, where technology might be indistinguishable from nature, where messages might be written in the very substance of comets and asteroids. It's a universe far stranger and more wonderful than we might have imagined, and we've only just begun to explore it. As we return from our journey through cosmic possibilities to the familiar comfort of Earth, we carry with us the expanded awareness that Atlas has provided. The night sky will never look quite the same. Every meteor, every comet, every unusual astronomical observation now carries the potential for deeper meaning, for connection to cosmic intelligence, for participation in a galactic community we're only beginning to perceive. This is the lasting gift of Atlas. Not answers, but an enriched capacity for wonder. Not certainty, but an expanded sense of possibility. It has reminded us that we live in a universe still full of surprises, still capable of challenging our assumptions, still worthy of our curiosity and awe. In a world that can sometimes seem fully mapped, fully understood, fully demystified, Atlas returns to us the gift of mystery, the joy of not knowing, the excitement of questions yet to be answered. The story of ATLAS is far from over. Its fragments continue their journeys. The data from its observation continues to be analysed. The questions it raised continue to inspire new research, new theories, new ways of looking at the cosmos. And somewhere out there, perhaps, other objects like Atlas are approaching, carrying their own mysteries, ready to provide their own contributions to our cosmic education. We are living in the golden age of astronomical discovery, when new instruments and techniques are revealing the universe in unprecedented detail. Every year brings new surprises, new categories of cosmic phenomena, new challenges to our understanding. Atlas is part of this ongoing revelation, a single note in a vast cosmic symphony we're only beginning to hear. Its passage through our solar system, brief and mysterious as it was, has added to the richness and complexity of the music. As we conclude our contemplation, we can appreciate how a simple comet, or perhaps not so simple, has taken us on a journey through some of the deepest questions humans can ask. Questions about intelligence and technology, about our cosmic origins and destiny, about the nature of the universe we inhabit. These are questions that define us as a species, that separate us from other known life, that make us unique participants in the cosmic story. Atlas, whatever it was, has earned its place in this story. It has become part of the mythology of our time, the scientific mythology that replaces ancient stories of gods and heroes with stories of cosmic phenomena and mysterious visitors. These new myths are no less profound than the old ones, no less capable of inspiring wonder and contemplation. They're simply based on observation rather than imagination, on data rather than tradition, on the universe as it reveals itself rather than as we might wish it to be. But even scientific mythology leaves room for mystery, for possibility, for wonder. Atlas occupies that space perfectly, observed enough to be real, mysterious enough to inspire speculation, gone before we could solve its riddles. It's the perfect cosmic koan, a puzzle that expands consciousness not through its solution, but through contemplation of its mystery. The universe seems to delight in providing us with such koans, such perfect mysteries that push the boundaries of our understanding while remaining just beyond our grasp. Dark matter, dark energy, quantum entanglement, consciousness itself, these are the great mysteries of our time, the questions that define the frontiers of human knowledge. Atlas, in its small way, has joined this august company, becoming part of the collection of cosmic puzzles that drive science forward. As we float here in the final moments of our contemplation, we can feel the vast peace of cosmic perspective. Our problems, our conflicts, our temporary concerns shrink not to insignificance but to their proper proportion. We're part of something immeasurably vast and old, something that includes mysteries like Atlas, wonders like interstellar visitors, possibilities like cosmic intelligence. This context doesn't diminish us, but rather elevates us, making us participants in a story of cosmic scope and significance. The fragments of Atlas continue their eternal journey, and we continue ours. Both are voyages of discovery, explorations of the possible, adventures in a universe that never fails to surprise and inspire. We may never know what Atlas truly was, but we know what it has given us: a renewed sense of wonder, an expanded awareness of possibility, and a reminder that the universe is far from fully known or understood. This is perhaps the most important lesson from our contemplation of Atlas. The universe is not a problem to be solved, but a mystery to be experienced. It's not a question that has an answer, but a continuous revelation that unfolds over cosmic time. We're privileged to be conscious at this moment, capable of observing and wondering, able to participate in the cosmic conversation even if we don't fully understand the language being spoken. Atlas whispered something to us in its brief passage through our solar system. We don't know exactly what it said, whether it was a natural phenomenon speaking the language of physics and chemistry, or something more intentional, more designed, more aware. But we heard the whisper, we recognized it as something worth attending to, and we've spent these hours contemplating its possible meanings. In the end, that's all we can do. Listen to the whispers from the cosmos, contemplate their possible meanings, and remain open to revelations we haven't yet imagined. Atlas has reminded us to keep listening, to keep watching, to keep wondering. It has renewed our cosmic curiosity and expanded our sense of what might be possible. And in doing so, it has fulfilled its purpose, whether that purpose was natural or designed, random or intentional. The universe continues its patient unfolding, revealing itself one mystery at a time, one wonder at a time, one whisper at a time. Atlas was one such whisper, a gentle voice from the cosmic darkness saying, "There is more here than you know, more than you imagine, more than you can currently understand." We've heard that whisper, we've contemplated its meaning, and we've been changed by the encounter. As we prepare to return from the cosmic to the personal, from the vast scales of interstellar space to the human scale of daily life, we carry with us the gift of perspective that ATLAS has provided. We've touched, however briefly, the mystery at the heart of existence. We've contemplated possibilities that stretch our imagination to its limits. We've participated in the ancient human tradition of wondering about the lights in the sky and what they might mean. The story of Atlas will continue to unfold in the years and decades to come. New observations, new theories, new technologies will add chapters we can't currently imagine. Perhaps one day we'll know definitively what it was, or perhaps it will remain forever a mystery, a question mark that reminds us of how much we don't know. Either outcome is valuable, either conclusion is meaningful, either ending is appropriate for a cosmic story of this magnitude. But for now, in this moment, we have what Atlas gave us: wonder, possibility, and the expansion of our cosmic imagination. We have the memory of its strange brightening, its mysterious fragmentation, its dissolution into the darkness. We have the questions it raised, the speculations it inspired, the growth in awareness it catalyzed. These are gifts that don't depend on final answers or definitive solutions. They're complete in themselves, valuable for what they are rather than what they might lead to. Atlas has become part of our story, and we've become part of its story. In the vast cosmic narrative, our brief intersection has created something new, something that didn't exist before. This contemplation, this wonder, this expansion of possibility. We've added our small contribution to the accumulated wonder of all conscious beings who have ever looked up at the sky and asked, "What's out there? Are we alone? What does it all mean?" These are the eternal questions, the ones that define us as conscious, curious beings. Atlas has reminded us that these questions are still alive, still relevant, still capable of inspiring wonder and driving discovery. In a universe that sometimes seems increasingly mapped and understood, Atlas returns to us the gift of mystery, the joy of not knowing, the excitement of possibilities yet to be discovered. As we reach the very end of our contemplation, we can appreciate the perfect incompleteness of the Atlas story. Like the best mysteries, it doesn't resolve neatly. Like the best questions, it doesn't have a simple answer. Like the best cosmic phenomena, it leaves us with more wonder than when we started. It's a story that expands rather than concludes, a question that opens rather than closes, a mystery that enriches rather than resolves. The fragments of Atlas are still out there, carrying their secrets through the darkness. We're still here, carrying our questions through our lives. Both journeys continue, both stories unfold, both mysteries deepen with time. In this parallel progression, this shared journey through the unknown, there's a kind of companionship, a recognition that we're all humans and comets, observers and observed, questioners and questions, part of the same vast, beautiful, mysterious cosmos. And so we conclude where we began, with a question that has no definitive answer but infinite value. What if Atlas was built, not born? The question remains open, the mystery remains unsolved, the wonder remains intact. And that's exactly as it should be. Exactly what we need, exactly what the universe in its vast wisdom and patience continues to provide. Not answers that end our searching, but mysteries that inspire us to keep looking up at the stars, keep wondering about our place in the cosmos, keep growing in our capacity for awe and understanding. The cosmic dance continues, and we're privileged to be conscious participants, able to observe, wonder, and appreciate the mystery and beauty of it all. Atlas was a brief partner in this dance, a mysterious visitor that reminded us of the vastness of what we don't know, the depth of what we might discover, the beauty of questions that may never be fully answered. In the end, Perhaps that's the greatest gift any cosmic phenomenon can give us. Not certainty, but wonder. Not answers, but better questions. Not conclusions, but an ever-expanding sense of possibility in a universe far stranger and more wonderful than we ever imagined.